For the next, let's go to see the application identification and the audit function. As you know that for Sundray, we have already integrated the application database, and we can identify the application. But how it works, let's go to see the details. The controller application identification is when the application traffic flows through the NAC through the characteristics to identify its application type. So after we after the identification, we can perform the application-based access control. For example, we have already identified that this traffic belongs to the Facebook, and then we can make the application. We can block the application, block the Facebook, and then to block this traffic. The flow control. Also, we can perform the flow control and the auditing. Also, we can block the network behavior auditing, the keyword search promotion, the application access promotion, etc. And for this picture, it's our application database signature. You can see from here, we can see that totally we have 5,423 applications in this database, and we have already divided into different types. For example, some application belongs to the email. Some application belongs to the security risk. Some belongs to the reduce the efficiency of the work. So all the information, all the application here, you can find it in this database. Actually, if you find that the application it's not in the database, and then you can customize the application by yourself. For the intranet applications, they are often unable to collect their network flow characteristic due to their private policy. Due to their private policy, so many intranet applications, we are unable to identify the traffic, whether it belongs to them. And then we can use the packet direction, the protocol type, or the IP address, or the port number, or the domain name, or some other characteristics as the rule to identify the application. The types of application, the customer applications are also suitable for the external network applications. So it means it's not only to customize the intranet application, you can also to customize the external network applications. For the application identification, we need to enable, we need to make sure that we have the application and the URL license. And then we go to the service to enable the application identification for the tunnel mode. The formal tunnel mode and the application identification for tunnel mode. For the tunnel mode, you can support app category-based access control, the flow control and audit, the network behavior audit, search term-based delivery, the app-based delivery, and the log output, etc. Here we give the configuration example to block it in the U2B for tunnel mode. Okay, the first step, we configure the access control policy in the in the authentication roles access control policy to add the policy to block the UTB. At the role, the service, its service or the application, it's a UTB belongs to the application. And when we select the application in the database, we can import the UTB context and then to search, and we select all. And for the action is to deny because we want to block the UTB, so the action should be denied. After we configure the access control policy of UTB, and then in the roles, we need to choose the application, choose the access control policy for the role, because all the control of Sundray is to use the different role for the management. For example, the employee role, we can block the UTB, and for the guest, we can limit the bandwidth. So the different role have the can call the different policy to make the network management. So for the role blocking UTB, we just add the blocking UTB access control policy, and we allocate this role to the user, and then the user, when they get this role, will get the policy too. Just now, it's for the central forwarding application control. Next, it's about the local forwarding application control. The implementation logic is after the AP receives the user's data packet, it will temporarily to cache the data packet on the access point, and then mirrors part of the data packet and send it to the controller for identification. So after the controller identifies the traffic, and the controller will give the corresponding instruction and will choose the access points whether to block the traffic or not. So many people, so many persons, they asked me the difference between the between the tunnel mode application identification and the bridge mode application identification. What's the difference? The difference is that for the tunnel mode, the user's data will be sent to the access controller directly. So we don't need to mirror the packets, the data packets. The user's data will be sent to the access, pass through the access controller directly. And at this time, the controller can identify the traffic. For the bridge application identification, because the data it's transferred locally. It's not sent to the controller. But so how in the bridge mode to identify the application? It's that when the access points they receive the user's data, it will mirror the data traffic and then send some packets to the access controller for identification. After the access controller identifies the traffic, it will return the commands to the access point, whether to block, whether to throw away the data traffic. So that's the theory of bridge mode application identification. In addition, the following points need to be noted is that the mirrored data packet is sent to the controller using the data tunnel UDP 7077 port. So if we want to realize the bridge mode application identification, we need to make sure this data channel, the port UDP 7077 is open. And then the more the mirror data packets are sent, the higher the accuracy of application identification. Just now I said that it will only mirror some of data packets. It's not send all, it just mirror part of the packets. So if you send the packets more for identification, and the accuracy of the application identification will be more higher. And the third is if the data packet mirrored to the controller, it doesn't receive a reply from the controller for some time. For example, we give 5 seconds limitation. If the data packet is mirrored to the controller, but it didn't get the replay from the controller more than 5 seconds, and we can choose to continue mirror the traffic to the controller, or we just to directly allow the traffic to pass. So for the bridge traffic control, how we to configure it? First, in the application center, in the service management, we need to enable the bridge traffic control to support app category-based access control, flow audit, the network behavior audit, the search term-based delivery, the app-based delivery, and the log output, etc. The second is to configure the access control policy for blocking the U2B. This is the same with this step is the same with the tunnel modes. And then to perform the policy in the role and in the bridge mode WLAN settings to assign the role to the user. In the tunnel mode WLAN settings, we assign the role to the tunnel mode user. And in the bridge mode WLAN settings, we assign the role to the bridged user. For the bridge traffic control, there are one more step. So in AP configuration, the bridge to traffic control, in this place, we need to enable the bridged traffic identification and control. Control by application here to enable this one, control by application, and then to add the new traffic handling policy for the role. In the traffic handling policy, we need to make sure that we need to choose the which role will be which role need to make the bridged traffic control, and for the traffic handling, it's application control. We choose the application control, and the data message and the DNS message is forward to and returned by controller, or you can choose to mirror to the controller directly. And for the advanced, it's the action upon traffic handling timeout. So if the access point didn't get the reply from the controller more than 5 seconds, the action will be allowed the traffic directly. So here is the explanation of each field of traffic handling policy. The first is about the role. The role indicates which user roles the policy will matches. And for the traffic handling, the application control, the purpose of this policy is to allow or deny the application. The next is application audit. The purpose of this strategy is to match the local forwarding user audit. So if we want to enable the audit function for the for the bridged user, you need to use the application audit. If you want to control the application, you need to choose the application control. And for the control DNS packets only, this one directly make control access to the domain name when requesting the DNS domain name resolution. This one means you don't need to resolve the DNS domain, and then you will, according to the domain name, to directly make the access control. For the DNS message mirrored to the controller, the AP copies the mirrored message to the controller directly. And for the forward to and returned by controller, the access point sends the mirrored message directly to the controller without going through the local. For the control message, the message without the data load, wrapping and mirroring this data is not helpful for application identification. For the SMB message will be released directly without application identification processing. For the mirror message by default, the two messages are mirrored, and the recognition rate is about 73. Actually, this number is high. If you want to, if you think that it's not enough, you can to change this number to mirror more packets to the controller, and the accuracy will be higher if more packets are sent to the controller for identification. For the traffic handling timeout, the data package mirrored to the controller, it doesn't receive a reply from the controller within the same set time. So it can set the processing action to continue mirroring to the controller for identification or directly release the traffic. That's for the tunnel modes and the bridge modes application identification. The next part is about the user audit. The user audit is divided into centralized forward user audit and the local forwarding user audit. So for this one, for this feature, it can also be divided into two parts. The first is the tunnel modes user audit, and the second is the bridge modes user audit. For the centralized forwarding user audit, the software version, NIC 2.4 version and the higher can support the centralized forwarding user audit function. And for the local forwarding user audit, the software NZC 3.2 R3 version and the higher supports local forwarding audit. But it can only record the source and the destination IP address, the source and the destination port, and the protocol number. For the NAC version 3.3, it can begin to support the local forwarding application identification and the network behavior audit. So it doesn't matter if you use the bridge mode or use the tunnel mode. It can it can support you to make the audit function, to enable the audit. For the centralized forwarding user audit, you can audit the HTTP outgoing content, including the web BBS, the posting, or the mail or the text uploaded through the web pages each other. But we need to know that the HTTP outgoing content audit that doesn't include the HTTPS, because the HTTPS is already encrypted, so we cannot audit the content of HTTPS. The second is the visit website download. This one including all the types of sites in the URL rule base. For example, the mail. The mail includes standard SMTP, POP 3, and MAP mails. Also, FTP is also supported. Next is the user Wi-Fi and online time. User traffic and the online time. For this one, you can audit the user's traffic and online time. For the local forwarding of the user's data, it can only audit the behavior, cannot audit the content, and doesn't support auditing the user traffic and the online time. So the notes here. The content encrypted with SSL cannot be audited, such as the specified content in HTTPS and SMTPS and PPP, POP3S cannot be audited. The WeChat, the QQ, or some cannot be audited. The content cannot be audited because it's an encryption. But the behavior can be audited. It means we know that you send an email or you use the WeChat, you use the QQ. We know that your behavior, your network behavior will be recorded. So what's the configuration of centralized forwarding user audit? In the application center service, to enable the tunnel forward mode, tunnel mode application identification, and application identification audit, and then to configure the audit contents. About the audit contents, you have the 3 levels. The first level is only audit the online behaviors, or the second level audit online behaviors and the contents. The contents not including the mail contents. The third level is the audit the online behaviors and the contents, including the mail contents. This is for the tunnel mode. In the for the bridge modes, how we config? In the AP configuration, the bridged traffic control to enable the bridged forward identification and control policy. And in the traffic handling policy, we choose the application audit. Is there familiar? Just now we make the bridged traffic identification. Here we choose here for the traffic handling, we choose the application control. But if you want to audit, here we choose the application audit. For the logging option, this one used to set the type of log to be recorded and the URL that is not audited. For the application exclusive list, the excluded application are not audited for the duration of the internet access. For this one, it's just to exclude the application. For the next part, it's the example, the configuration example. First is the tunnel mode user audit. First, we configure the audit strategy to create the application audit policy in the application role application audit policy, and to choose which kind of content you need to audit. And then in the role to call this application audit policy. If you need to audit the users' internet traffic and the duration time, you need the additional configuration. Okay, later we will say how to audit the users' internet traffic and the duration. So after we perform the application audit policy to the roles, and then we need to allocate the roles to the user. So in the LAP configuration, WLAN settings, the role assignment, we assign the role to the user. So the user, when he connects to the Wi-Fi and his behavior, the content can be audited. So if you want to audit the traffic and the duration, how we can make it? We need to check the traffic and the duration option. We need to clean the traffic and the duration option in the audit policy. This is at the last part of application audit policy. After we enable this one, and then we need to go to the wild line boundwise to bind the line with the interface. This step is to bind the controller uplink interface with the line. And then in the bridge traffic control, the bridge to enable the bridge traffic identification and the control policy. For the traffic handling, we use the application audit. For the start, we enable the flow management system in the flow control channel to enable the boundwise management system. In the flow quota, flow control, the BM channel here to enable the audit of traffic and the duration. Because if you want to audit the traffic and the duration, you need to enable the boundwise management system. Note, the local forwarding, it doesn't support audit the user internet traffic and the duration. For this function, it's not supported in the bridge mode. For the bridge mode user audit, we need to enable the local forwarding identification control policy, and then to configure the audit policy to perform the policy in the role, and then allow the allocate the role to the user. Yeah, this is for the local forwarding user audit. For the configuration, it has not so much difference. You just need to make sure that if you want to if you want to use the bridge traffic, if you want to audit in the bridge mode, you need to enable the bridge traffic control. And for the traffic and the duration, it can only support in the tunnel mode. Okay, that's 2 points. It's the 2 key points of the user audit.